Hey everyone, today we'll be going over question 5, Backyard Zoo of the Spring 2024 final. So in this question, Michelle is trying to organize summer gift baskets for her backyard monkeys, but they each require different supplies. Help her implement the class monkey to help her decide how many M&Ms, silly bands, and ring pops to put in the gift baskets for each of these monkeys in her zoo. So we can see that we are given the class monkey, and we can take note that it has a parent class called land animal, as well as an init method, a count silly bands method, and a items and gift basket method. So in question A, we are given the implementation for the land animal class. And if we go through this, we can see that the init method takes in a species and a weight, and it initializes the species and the weight whenever a new instance is created, but also it initializes a ring pop attribute, which is set to 3 every time a new instance is created. It also has a count M&Ms method. So now, since monkeys are land animals, we are tasked with filling in the blanks to make the constructor of the monkey class inherit from the land animal class. And in addition to what's initialized for every land animal, we have a name for each monkey. Yeah, so if we go through the monkey class, we can see that the init method also takes in a species and a weight, similar to the land animal, but it also takes in a name. So we can see from the doc test that if a new instance of a monkey is created, and we call that instance George, if we call George.name, we will get George, and George.species would return curious monkey, and George.weight would return 10. So in order to bring all of the land animal attributes into the monkey class without having to copy over code or rewrite the code, we can use the super init method where we pass in the same parameters as the land animal class, which are species and weights. And what this does is it basically, whenever we create a new instance of the monkey class, it initializes the species, the weight, and also the ring pop from the land animal class. But in the question, it says that we also have a name for each monkey, so we have to set that attribute. So we can do that by saying self.name equals name. So whenever we set self.name equals to name, not only do we initialize all of these attributes whenever we create a new instance of the monkey class, but we also initialize a name for each instance. So that was question A. Now we can move on to question B. To count the number of silly bands to put in each monkey's basket, Michelle came up with a formula to optimize her pet monkey's happiness. All of her monkeys start off with 10 silly bands. She then adds a silly band for each number between 1 inclusive and the length of the monkey's name, which is exclusive. So we should definitely keep that in mind. And we are also given some doc tests that we should go over to get a good understanding of what the method does. So in this doc test, we can see that a new instance of the monkey class is created, and we assign that instance to the variable monkey1. And when we call the count silly bands method on monkey1, we can see that the method checks the name of the monkey. So recall that we are passing in the name, the species, and the weight, but we only really care about the name. So the method checks to see what the name is, which is Bob, and it checks to see the length of the string, which is 3, and the range would be from 1 inclusive all the way to the length of the name, which is 3, but we remember that it is not actually counting the last value, which is 3, so it's exclusive. So if we list out this range, it would be 1 and 2 because we're not counting 3. And of these two values, only one value is an even number, which is 2. So if we can see here, only one silly band is added to the 10 starting bands that monkey 1 starts with for a total of 11 bands. Now, similarly, we can go to the second dog test where a new instance of the monkey class is created, and this time we assign it to monkey 2, and monkey 2's name is Stephanie. And we check to see the length of Stephanie, which is 9. So we go from 1 inclusive all the way to 9 exclusive. And if we list out the range, we will get 1, 2, 3, 4, 6, 7, 8, because we're not counting 9. And if we count the number of even numbers in this range, we will get 1, 2, 3, 4. And this is why we add 4 to the number of starting silly bands, which is 10, for a total of 14. So if we look at the skeleton code, we can see that there is a for loop. So we are iterating over something, and and there is a if conditional, and if this conditional passes, we will add 1 to this variable called res, and in the end, we are returning res. So from this skeleton code, we can kind of infer that res will be the variable that we are keeping count of these silly bands in, because we are adding 1 to that variable every time we get an even number. So we can initialize that variable with res equals 10 because each monkey starts with 10 silly bands. So now we can enter the for loop, and in this for loop, we want to iterate over the range of the length of each instance's name. And we can recall that range takes in a starting number, which is inclusive, and a stop number, which is exclusive, and also a step, an optional step, but you don't have to include that. Its default value is set to 1. Yeah, so we can say for I in range, since our starting value from the question is 1, we would put 1. And to find out the length of each instance's name, since each instance's name is a string, it is valid to say the length of, and if we recall, we set self.name equals to name, so we make sure that it is self.name. And we want to make sure that we are saying self.name instead of just name because each instance has a unique name. So if we say self.name, we are referring to that instance's name specifically. So now we can enter the if condition, and we can see that the if condition, if this is true, we are adding 1 to the variable that we created, and we want this if condition to be true whenever the current value that we are on is an even number. So we can use the modulo operator with I modulo 2, 0, and the modulo operator basically checks to see if there are any remainders left behind whenever you are dividing. So we can run through an example. So Stephanie starts out with res equals 10, and for I in range 1 all the way to the length of self.name, which we said was 9. So 1, 2, 3, 4. So our first I value is 1. Now we check if 1 modulo 2 is equal to 0, and it is not because it has a remainder. So we don't execute this statement, but we instead move on to the next iteration, which is I equals to 2. Is 2 modulo 2 equals to 0? And the answer is yes. So we execute this statement, which is res plus equals 1. So we are adding 1 to 10, which is 11. Now we repeat the same process. Is 3 modulo 2 equal to 0? No, so we move on to the next one. Is 4 modulo 2 equal to 0? And the answer is yes, so we add 1 to res. And is 5 modulo 2 equal to 0? No. Is 6 modulo 2 equal to 0? Yes, so we execute the statement right below it, and we add 1. And is 7 modulo 2 equal to 0? No. Is 8 modulo 2 equal to 0? And the answer is yes. So res is equal to 14, and that is our return value, which is 14. Now we can move on to part C. Now we want to implement the function items in gift basket, which will return a 3-element list that represents how many associated M&Ms, silly bands, and ring pops to put in each basket respectively. So essentially we want these methods to return these 3 items in a list form and also in order. So if we look at the skeleton code, we can see that the return value actually already returns a list, so we don't need to create a new list. And there are 3 blanks for 3 of the items that we need to put in the list. So we can start with the associated M&Ms. If we go back into our land animal class, which is the parent class of the monkey class, so this is a valid thing to do, we can see that there is actually a count M&Ms method, and if we look at the description, it says that it returns how many M&Ms to put in a land animal's basket. So this is exactly what we want as our first item in our list. So to call this method, we would need to use self dot count M and M's. And we want to make sure that we are including parentheses because we are calling the method. And we don't pass in self, as you can see here, because by calling the self dot count M&Ms, self is kind of being passed in the background. So we don't need to pass in another self. Great, so now we can move on to silly bands, and from the last part, we actually implemented this method, so we can repeat the same process we did with self.count M&Ms. We could say self dot count silly bands, and also make sure that we are calling the function, and we're also not passing in self for that same reason, because when we say self.count silly bands, we are calling the method on that instance. Great, so now our last item is ring pop. And in part A, we use the super init method on the init method of the monkey class. And if you recall, what this method does is it basically initializes all of these attributes whenever we create a new instance of the monkey class. And one of these instances is the self.ringpops attribute. So all we need to do is use that variable self.ringpops, and that is for question C. Now we can move on to part D, Michelle has now decided that all the monkeys that are of the species Curious Monkey deserve an additional 3 ring pops, but only if the monkey's name is longer than 5 letters. Which of these actions should Michelle take to adapt her code? The change should not break any of the other parts of this question. We can go through each option. If we look at the first option, it is modify the constructor method of the monkey class. So if we look at the constructor method of the monkey class, which is the init method, what this option is asking us to do is we're first checking to see if self.species is equal to curious monkey and the length of the name is greater than 5. We want to add 3 to self.ringpops. Now, this is a completely valid way of modifying the code because the constructor is responsible for initializing attributes when a monkey object is created. So since the number of ring pops depend on the species and name length, we should modify the constructor to handle this condition. And since the constructor runs once per object creation, which is the best place to initialize these attributes, we are correctly checking to see if self.species is equal to the curious monkey species, and if the length of the name is greater than 5, we are modifying the self.ringpop attribute without harming any other part of the code. And we are also making it specific to that instance itself. Great, so we can check off this for now, but we should also go through the other options to not only make sure that the option that we've chosen is correct, but also identify what is wrong with the other options. So we can move on to this next option, add a new method count ring pops to the monkey class. So this is actually not what we want because if we were to call self.ringpops on, for example, this instance, George, since George has a species of a curious monkey, we would still get a return value of 3. Only then when we call self.count underscore ring underscore pops will we get the number 6, but 6 isn't really assigned to self.ringpops yet. So later in the code, we would have to write something like self.ringpops equals self.count ringpops. And this is invalid because we are changing the code instead of just initializing it right off the bat when we create the instance. So we can move on to the next option that says modify the constructor method of the land animal class. If we go to our land animal class, we can see that it has 3 attributes, which are species, weight, and ring pops, as well as the variables that get passed into it, which are species and weight. But if we recall what Michelle wants to do, she wants to add ring pops only if the monkey's name is longer than 5 letters. And the land animal class doesn't really have a name attribute, so there's really no way of checking the monkey's name. So this would be an invalid option because it will cause an attribute error because this logic is specific to monkeys and not the land animal class in general. So we can cross out this option. And for our last option, add a new method, count ring pops to the land animal class. So similar to the second option we talked about, this would also be invalid because the land animal class should not have any special logic for monkeys. The whole point of inheritance is to specialize the behavior in subclasses like monkeys, so we don't really want to modify the parent class, which is the land animal class. And if we add a new method called def count underscore ring underscore pops to the land animal class, similar to what we did with the monkey class, the same logic occurs where we are not really assigning this new value to self.ringpops yet until we need to change the code. And if we call self.ring pops on a monkey species with the curious monkey species, we would still get the return value of 3 until we reassign it. So the correct answer is modify the constructor method of the monkey class. So that is it for question 5.